Okay. So I think we will start now. Do you see my slides, everyone? Marcelino?
Yes, I can see your
Okay,
slide.
perfect. So welcome everyone for this, I think our 14th, 15th talk of the EDT seminar in the third series. And today we are very happy to welcome another exciting talk among the ones we had in digital twins from Marcelino Rodriguez. So just a reminder, this final talk of the series 3, and we will have in 2 weeks from now another panel discussion, similarly as we had in the 2 previous series. So just a quick word before I give you the floor, Marcelino. So he is CTO at Couture Technologies, and he works on fashion technologies, fashion technology startup. And he leads the digital twin activity there. He will talk about it in more details. He also has a PhD. He held a PhD from the University of Rennes, where he worked previously on optimizing the compiler for running simulations and program in a faster way. And today he's going to talk about digital twins for fashion application, the twin Chic. So again, we are very happy to have you among us, Marcelino, and I will let you share your slides for the presentation.
Hey, hello everybody. Let me share my screens. Hopefully you can see my presentation now.
Yes, I can see it. Can you? Yes, perfect. I see.
Okay, perfect. So thank you so much, everybody, for having me here, giving this talk. Hello, Jean-Marc. I saw you are on the crowd. Special salutation for you. It's very nice to meet you again. So yes, my name is Marcelino Rodriguez. I'm the CTO of Couture Technologies, and today we're going to be talking about digital twins in fashion, specifically in the world of virtual try-on technologies. So why virtual try-on, and why what I'm going to tell you guys today, it's something that matters. The thing is that currently the fashion world is undergoing a strong transformation. There is this huge push towards moving to online sales. So there's this with the world and everything, the way that the things are going, the fashion companies are having this pressure to move their sales over to online stores, basically. And companies that have not ride this wave correctly have been forced to close. And in the United States currently, giants like JCPenney, which they decided they were not going to go online, they were forced to go bankrupt, which it was a big shock for everybody. The thing is that the online world has its own challenges, and the first challenge is that every time that somebody goes to to a website, there's only a 2% chance that that person will buy something online in a store, in an apparel store. And so online store has a very low conversion rate, and that's a problem in itself. But the biggest problem of all that they are facing right now, that they don't face in a store, is basically returns. When you go into a real brick and mortar store, you can try your clothing, but online you cannot. So that means that depending on who you ask and depending on where you read it, the statistic can vary, but around, for every 3 garments sold on an online store, 1 is going to be returned for sizing problems. Usually in brick and mortar, this is only the 8%. So for 100 garments that you sell, you will get back 8 or something like that. But here it's like 33%, 40%, 50%, depending on the store, how well they do things. But in general, it's a massive amount of returns with compared to the sales. So this has cost companies in the United States around $100 billion every year. So it's a lot of money. And so, from an economical standpoint, it's not only a problem from an economy, but also for the ecology, because many times these returns are returned into the store, and because it's easier to throw them away, the company doesn't process them and put it back in the store. They just throw it away into landfills. And there are studies estimated that says that around 5 billion pounds of garments, they go into the trash every year because of returns. And it's also a social problem, because when you close all these stores, there are going to people that are going to get without a job. And you have to, like, if this company is closed, there's is a big problem for society and the economy. And we are facing something that in the United States has been called the retail apocalypse. In 2020, 11,000 apparel stores closed physically all around the country. And you could say, well, that was because of COVID. And it's true, it's because of COVID, but also the trend was, steady before. In 2019, 7,500 apparel stores closed in 2019. And then in the year before, more than 6,000. So it's a trend that's been going. And I wanted to go back to the ecology thing, and with a little bit of visualization. Here's me. 5 billion pounds of landfill. It's pretty much every person in every family in the United States throwing a load of clothes, a load of clothes into the garment. And that's me holding a load of clothes in my hand. That's what I will throw away. So you can imagine every family throwing that kind of clothes into the trash, and that would equal the problem with the returns. So all the return clothes that are going to landfills, it will be something like that. It's just a little visualization to give you the size of the magnitude of the problem. So what we're trying to do here, as a company, it's we're trying to create a virtual try-on technology that will tell you how garments will fit in your body. The idea for a virtual try-on, it's very straightforward. It's technically extremely difficult to do, but it's the idea is straightforward. You go into a website, you select the garment that you wanna try, that you input your body measurements using some method. There are several methods, and we're going to discuss them in this talk. And then the tool will show you how the garment will fit on your body. And we have been doing some work already on this. And let me show you a demo that I have prepared here. As soon as my computer froze. I'm sorry, guys, I'm having problems. Just a second. Sorry about that. I was having trouble
Oh, it's okay.
with Zoom. Okay. So let me bring you to our demo website. We've been working on this technology for 3 years now. So here's the website that we have in order to, we bring potential customers here and we show the technology working for them. So I'm gonna do a small demo for you guys. So I have already loaded my measurements here, and I'm going to try this jean because I'm a jean and t-shirt kind of guy. So hopefully, so the tool, as you can see, allows you to zoom in, to turn around. We've been doing digital simulations for we have two twins working around here. Well, the human twin, we're going to talk about it, and we also have the garment twin. We are currently the only company in the market that allows you to do a complete outfit So for example, the other companies in the market, they don't allow you to choose, you know, a full set of outfit. They will only allow you to try one garment. As you can see, well, we have here the jeans with the jacket. The tool will allow you to change colors, but not only change colors, but also change sizes. So this is the correct, the tool is predicting, you know, it's recommending me to wear an L jacket. This is the one that I wear, and a 36 pants, which is the one that's my size. So this is my avatar. And you know, but I can also see how, you know, smaller or bigger garments will look on my body. I'm going to choose a double XL to visualize how would that go, because you know, people, something that people hate about size recommendation tools is that they tell them what size to wear, and maybe your style is that I would like to wear something, you know, tighter or something looser. So here, the double X, as you can see, it's too big for me over here on the waist. So yeah, it's probably not my type. Sometimes it's difficult to see from the visualization only. I'm going to go back to L, and we have this technology that is called the fit map, and the fit map tells you, I don't know if you guys see it. By the way, this URL is live. You feel free to go there and share with your colleagues anytime. I don't know if you see the the um, the legend over here. Hopefully you will. But basically, what this tells you is that in this area over here is going to be loose. Your arms is going to be very loose. If I go into, say, and small, the fit map probably will tell me that the jacket will be tighter. So this allows me to go, and as you can see here, it's telling me that it's going to be very tight on my chest. Probably it's not going to close. So this is the size S, and we have this visualization to tell the users. You can see it's really tight. It's, you know, you can see the chest of the avatar already. So this is a numerical simulation. As you can see here, it tells you, well, hey, it's not going to fit. So that's our tool. And you know, just a quick presentation. We have a bunch of other garments there to play with. I really like the way you know, for example, this shirt fits on me. So since I have a little bit of time in my presentation, probably going to show you the way it fits. And you know, it's a nice shirt, and I already have it. So yeah, you can try different, this is just to say that you can try different combinations of garments, colors, and sizes, and you know, hopefully it will give you a better idea before you buy. So coming back to our presentation, we are here to talk about twins. I'm all the time going to ask, can you guys see my full presentation? Okay,
Yes,
perfect.
yes, yes.
Okay, great. So in order to, we're going to, we, as I said, we are here to talk about digital twins. And today we are going to talk about two specific twins that we need to get this application working. We're going to need a twin for the human body, a digital twin for the human body, and we're going to need a digital twin for the garment. And I may be not very disciplined and may call the garment twin also the cloth twin, because it's basically the same thing. And then we're going to talk about Scrap Hat, the engine, the Couture engine that makes these two things work together. We're going to talk a little bit why it's difficult to have these twins working, you know, the state of the art. And, you know, at the end of the talk, I'm going to be finished with some presentations on the things that we would like to share to the community. So the challenge is to build a human twin is that the human body has an extremely complex and variable shape. It has just too many measurements. And funny story here, when we started this project, we started looking at a bunch of people naked, just to see, you know, like to understand the complexity of the human body, and we looked like a bunch of weirdos in the co-working space that we were rented, like just looking at pictures of naked people to understand the complexity of the human body. But we came out of there realizing this is not an easy problem. It's too much variation. Then for the simulation part, human body, it's has soft tissue, and soft is usually hard for simulation problems. But specifically for virtual try-on, and specifically for virtual try-ons, we have UX and UI problems, which is that in order to get your measurements right, traditionally there are just too many measurements. People, some bespoke can go as far as 100, 130 measurements. Is crazy. You can take it down if you want to like 32, but there's no way a user is just going to go and enter 32 measurements of her body. It's like too complicated. So that's one issue. And then the other issue that we have is what is called the uncanny valley. The uncanny valley, it's a psychological phenomenon in which you go really, really like super realistic, or just don't go at all, because otherwise the user will reject the visualization that you do, because it looks creepy, basically. And then we have problems with users' self-perception. So that's something that in previous technology, they use scanners, with high resolution scanners, to scan people. And that will yield that persons will start seeing the defects, like what they will call something that they would not like about themselves, or like I'm too big, I'm too hunched, I'm not too tall, and then they will start rejecting the avatar, and that's something you don't want. So let's talk about an overview on how human twins are used or built for virtual try-on. The first method is basically what I would like to call your nearest twin on the database. And basically the companies and the organizations that are using this for virtual try-on, what they're doing is that they're getting a huge database of human shapes. Well, huge, depending on your idea of huge, it could be around tens of thousands of scans. And what they're going to do is that you enter your measurement somehow, and then they will match you to the nearest, like the scan that looks more like you, your nearest scan, basically. So it's easy. This is easy to do once you have the data. You don't have to like do anything on top of just having the data, and then the process is very simple. It simplifies the interaction with the garment twin, as we will see later, and the shapes keeps the details of the human body, which could be good or bad depending on how you think about it. And unfortunately, it's not terribly accurate, because it's not going to necessarily have your measurements. It's going to have measurements that are close to you. So then there is this huge bag. I'm trying to, of course, I'm not going to go very deep, so I'm going to generalize a lot. There is huge bag of mathematical bodies, mathematical models for the human body. And pretty much the way this works, it's somehow they represent the human body as a model that modifies a topological constant mesh based on parameters. So they have a standard mesh, what I call the template mesh, and they will modify that based on parameters on a mathematical model. And it's more accurate for virtual try-on, as you will have a mesh that will have your measurements. That is guaranteed to have your measurements. So if you say, for example, I have 36 span line and 44 chest, that mesh will have your measurements, which is a good thing. Something that we like about these measurements is that they tend to smooth the human body, and that tends to lower the fact that users will reject their avatar based on self-perception, something like that. It has we have been, the problems that we've been having with this method is that some parts of the body lose detail, specifically on the chest area and the buttocks, but it's overall, I think, is the best option out there right now. And you can also use a picture. Another way to go about this is not numerical simulation. So far, basically shows two options of human twins for simulation. But another way to go about this, using generative adversarial networks, and basically generative adversarial networks are some sort of automated Photoshop, and then you just need a picture. Unfortunately, and take this with a little bit of salt when I say this, because the progress in this area is very fast and it's amazing. Right now, they cannot provide feeding information, and they cannot provide 3D information. They can turn you around. There are some advances definitely about like taking a picture and turning it into 3D, but it will definitely use some parts of this method. So it will not be straight pictures. So it will have to use some of the back. So that's why I say there's no feeding and no 3D if you go just with picture. So what Couture has been doing so far, first of all, we developed a measurements by pictures method. So, pure machine learning, computer vision thing in basically two pictures. It takes two pictures of your body and it's able to get your measurements. And once we're able to get your measurements, we're moving into one of the models that will create an avatar based on measurements. We've been developing this technology for a year, and right now we are the only company that can provide this on your website. So we are the only company that integrates this technology completely on your website. The rest of the company either ask you to download an application or ask you to go away to another website. This is something our prospects like a lot, because it doesn't interrupt the flow of the buying, which is very important for them. And then we for people that are not comfortable by taking pictures of themselves for just about any website, we've been working real hard to understanding what from all the human measurements in the body, what are the most important ones for fitting. And we did a lot of work there of statistical correlation, also social, what are the measurements that people will take easiest, and we put that into our application. So let's talk about now the garment twin and the challenges to create the garment twin. Cloth is one of the hardest objects to simulate in in my career. I've been working with simulations a lot, and cloth is particularly challenging. It's very deformable. It has to interact with the avatar. It has to interact with itself. It has to interact with other layers of clothing on top of it. So it takes a lot of resource to do it right. And to make the challenge even harder for virtual try-on technologies, you have to do this for thousands of people concurrently, because you basically will be a bunch of people going into your website all the time, and you will have to do these simulations, which are very resource intensive, really quick, and doing a lot. So it's something that at this point, I guess, so as far as I know, we are the only company pursuing this path. So hopefully, wish us luck. I think we're almost there. But yeah, it's something that nobody has ever done to this point, being able to simulate in real time for virtual try-on, and this is for a problem of scale that you need, of course. So that the way you create the virtual twin for the try-on is that, in general, this kind of simulations is that you design the garment, the 3D garment, using 2D patterns, just like in real life. Our garments are built from 2D patterns that are sewn together, and then you start defining virtual forces that will attract this pattern into each other, and then you start running the simulation until the point in which it comes together like in this picture. So this takes around 1-2 seconds for standard engines. We are been looking at doing this under 9 milliseconds, and we've been so far successful in doing it. And that's our secret sauce. That's what we do at Couture mainly. So how the simulations for clothing are done currently. The leading, the state-of-the-art family of methods this is a big bag. This is a big family of methods. It's the point particle simulations, and cloth is simulated as a collection of small particles that are held together somehow. And when I say somehow, that's the family. Some uses Lagrangian equations, some use Euclidean equations, some use forces between tensors and stuff like that. There are many ways to simulate this depending on how you want to optimize that. So the good thing is that it can produce 3D. It's a 3D simulation, and it can simulate fit out of the way, because obviously if you start simulating your garment top of the avatar, as the cloth start to stretch, you can get the information that they're stretching there, and obviously it's not going to fit on your body, or you're going to feel this way or that way um, in with the garment on top of you. But it's like the most expensive thing ever, so that's the challenge there. So as you can see, well, this is something I already showed in my demo, and that's something good that point particle simulations can do for you. It's that they can, for virtual try-on specifically, is that they can um, provide fitting information right at the bat when they are simulated. So on the other spectrum, totally, of this is not simulating clothing, but the other spectrum of generating the garment twin, it's the generative adversarial network. So other companies in the virtual try-on field, they have been going into this radically different way of doing things, which is trying to use generative adversarial networks, which is a machine learning algorithm, to create a fake picture of how would you look wearing a garment. There are advantages to this method, and the advantage is that the network generation is super fast. Another good thing is that it can show the garment on top of your picture, not of an avatar, which it will add to the realism of the simulation. Unfortunately, they, at this point, again, whatever I say, generative adversarial network in the machine learning field in general is super, it's advancing a lot. So, but as far as I know, at this point, they cannot produce 3D, and they cannot account for fit, because, as I say, they are, the way I explain this to our prospects is that it's a sort of automated Photoshop. So you can, it will, if you want to put these garments on top of whoever, and no matter how big or slender the person is going to look good. And in general, what I've seen so far in the usage of this technology is that the network, it's being trained with pictures of fashion models. So it looks well for slender people, but it doesn't look so well for people that, like me, that are, more on the big side. So it, start getting out there because, of the search space that was defined for training. But again, this is something that probably is simple to fix, having more data. We're not using this technology, like I said, but it's definitely on our radar, because we are following very closely, because it's something definitely to take into consideration. So while we're not using it right now, I don't know if we'll be using it in a year now or so from now. So yeah, something to take into consideration for sure. So now let's talk about we've been talking about how to create the human twin, and we're going to talk, and we already talked about how to create the garment twin. So let's talk about them working together. These are actual simulations of our engine for two different people. As you can see, there's a model that we presented. This is one of a fashion event that we went in Nashville, and she's wearing a summer dress. And well, the simulation is next to her, and we have also this is our our COO, and he's modeling workwear, basically, and we also were able to simulate that on top of his avatar. So that's and the engine that put these two twins together, we call it Scrap Hat. So many people ask us, why Scrap Hat is different and how it's novel with compared to what is already there in the market and for simulation engines. And the thing is that in the way the best I explain this is the difference between a luxury sedan and a bullet train. So current clothing simulation engines are designed are built to design clothing. So you can in that sense, you can go like with a luxury sedan, you can go whatever you want. So the clothing engines right now are meant for you to design new clothing. It can take you whatever your imagination want to go, but it can only take you, the designer. So it's one person, or a team of designers, like a small set of number of people. Like just like the luxury sedan will take just 5 people at most into whatever they want to go. And this uses all the resources on your computer to take this small number of people wherever they want to go, to take this small number of designers design whatever it's on their heart. On the other hand, Scrap Hat, our engine, is more like a bullet train. The bullet trains can only go fixed place. We received the garment already designed from our client, and they said to us, this is what you have to simulate, and you are not, we are not allowed, not we are interested in making modifications to the garment. That's it. So just like a train is, from point A to point B, it's fixed. And this allow us this, the fact that the garment is already given us pre-hand and it's fixed and it's not going to change, allow us to do all sorts of optimizations that allow us to simulate that same garment in different body shapes much more faster than a traditional engine will do, because of this knowledge that we have beforehand. So just like, a bullet train, Scrap Hat is meant to simulate one garment that is pre-designed for thousands of people, just like a bullet train is from one A to point B, a bunch of people. The Scrap Hat uses a lot more resources than your traditional cloth engine. Right now lives on, super servers like 120 CPUs and like super big GPUs and stuff like that. But the cost is amortized by the fact that there are a lot of users that are using it at the same time. So now I would like to talk about how do we make our twins something exciting for the community that we want to share, something that we're working, and definitely, if you are interested in what I'm going to say next, feel free to reach out. We're willing to share the code, we're willing to share the design, everything, so you can use it. And we are developing 2 tools that I think that are useful for the the digital twin community at large. The first one, I like to call it the Gorilla Scanner, which is an open scanner, an open human scanner. And then I'm going to talk about Roboloom, which is the tool that we use to create garment twins. So the first thing that I would like to talk is about the Gorilla Scanner. It doesn't look really impressive. If you ever seen in the market right now, there's a lot of these super big scanners that are super shiny and super accurate and big. And it would be really simple for us just to buy one of those. But our experience had told us that the problem with the scanning and people, and you will like to scan people to get data, to do all sorts of mathematical models, to create their twins. You scan people for all sorts of reasons, to get information about the trend in sizings for different garments. So the need for scanning people, it's out there. There are many companies developing scanners. Why would we create a new scanner, another one, and a gorilla one to make it even more questionable. The thing that we have found when scanning people is that the difficulty is not to get your hands on a scanner. The difficulty is to get your hands on people. So you need thousands of people. So if you're going to have one of those big room scanners that has like all sorts, has thousands of cameras and they're super accurate and stuff, basically the data that you can get using those scanners is around 30 people, 40 people. There are several the leaders right now, the guys from SMPL, when you look at the leaders in research, they have all this technology. When you look at their data sets, they're very small because it's very difficult to get, you know, thousands of people to get into your building. It costs a lot of money. So we, sorry. So we decided to go the other way around, which is to take the scanner into the people. So we decided, okay, how do we create a scanner that is portable, that is easy to use, and, you know, we can make it open so can everybody can have one on their homes. So right now our scanner is the only component that you will not find, that is difficult to somehow find in a household. It's basically a lidar camera. These cameras run for $200 or so. So the whole cost of the scanner is not thousands of dollars like your usual scanner. It's going to be, for this particular setting, it's going to be less than $500, and you can take that, put it on your back, and go whatever you want with the users. Now, the good thing about scanners is that you want, you know, multiple cameras around you. The way this scanner works is that it's Bluetooth, it's connected to many cameras, but you can add cameras as you go, depending on your budget. So, you know, they will connect automatically to the software that is running on an Android application, basically. So it's super open and super portable. You can add cameras as your budget allows you. You're not, you know, constrained with a big, you know, chunk of money, like other scanner that they say, you know, this is $10,000 or bust. You can go as you need and as your resources allows you. And, you know, the software, you know, we're probably going to go with the, if this is of interest to the community, probably we are open to talk about open source. The scanner, you know, also is able to connect to, you know, home devices like smart scales that you can have in your bathroom, and they will also gain your weight and stuff like that. So, you know, it's super open. It's like Gorilla. We can go whatever we want with it, and we're capturing data with this one. So if there's this interest of anybody for your data collection things, just reach out and let's talk about it. And then, you know, that's for the human twin. Let's talk about how do we create the garment twin. And we've been developing a tool that we call RoboLoom. And the reason we've developed this tool is because the current tools for digital garment twin creation, they were not, you know, too optimized for virtual try-on. Again, they were designed to create new clothing and stuff like that, but we had needs like, you know, massive sizing, a lot of automation for a lot of garments, a lot of people. So we decided to go completely create our own tool. And then we say, hey, you know, it would be awesome now with all the metaverse going on right now, and, you know, people definitely like in fashion schools and stuff like that, it would be awesome if we set the tool free forever for everybody, and we give this to people all over the world, and they design their clothing using RoboLoom, and now we have the virtual garment twin that can go directly into a virtual try-on without us doing anything. So that's why we are planning to open RoboLoom for free for everybody, so everybody can use. At this point, the tool is definitely not on a state that, you know, will be easy for everybody to use, but it's definitely something on a roadmap. And, you know, if you are interested in creating virtual garments for the metaverse, or, you know, basically fashion or whatever, come talk to us and we can talk about the roadmap for RoboLoom. And this is something we are going to open for the community as well. So did finish my presentation. Thank you so much, guys. And, you know, I'm happy to take any questions you may like.
Thanks a lot, Rodrigo, for this nice talk. And yeah,